For tonight's Green Report, we go to the North Pole, where data from the U.S. National Snow and Ice Data Center shows that sea ice has hit record-breaking low levels. Arctic sea ice in June 2016 was recorded at 4.09 million square miles, roughly 100,000 square miles smaller than the sea ice extent in June of 2015, which was the previous record low for sea ice in any previous month in June in human history. Christian Haas, an Arctic sea ice geophysicist at York University, in Toronto, told UPI that in 30 years, the area has shrunk approximately by half. There doesn't seem to be anything able to stop this trend. Climate scientist Ed Hawkins recently released another spiral graphic similar to the one he published earlier this year showing global temperature change, this one showing how Arctic sea ice has declined over time. This is really bad news for the Arctic because once the sea ice melts, the water below is going to start rapidly warming, leading to accelerated Arctic warming and pushing us ever closer to a climate change tipping point. For more on this, I'm joined now by Professor Jason E. Box, climatologist and glaciologist for the Geological Survey of Denmark and Greenland. Professor Box, welcome back to the program.
Thanks a lot.
It's great to have you with us. Why is what's happening in Greenland and other parts of the Arctic so important to understanding how climate change all around the world is happening and progressing?
Climate change in the Arctic is happening about 2 to 3 times faster than it is at the lower latitudes where most people live. And so that effect we call Arctic amplification is actually changing the weather patterns here in the mid-latitudes. That's the direct connection between Arctic climate change and the weather that we experience. That can mean cold winters here. It can mean hot winters. And that's the signature of Arctic climate change is impacts down south that it's more extreme weather, more drought, more flood, more heat wave, more cold waves.
Mm-hmm. As part of your Dark Snow project, you've been conducting extensive research on Greenland related to how quickly its glaciers are melting. What have you found?
Yeah, we're crowdfunding a communication project at darksnow.org, and we've successfully been launching expeditions to Greenland to sample how much increasing wildfire is darkening the snow and ice-covered surfaces. And we're able to find that this dark soot, it can tip the balance between freezing and melting conditions. It's an additional amount of light-absorbing material. And so we get those science findings out to a public audience. As I said, it's a communication project. So you go to darksnow.org and you can watch videos that we've produced. We're engaging in citizen science and just trying to raise awareness through kind of unconventional indie media channels.
It's great work. And what have you learned so far? What any findings that you'd like to share with us?
We have found elevated black carbon during the fire season, and that absorbs more sunlight. That extra heating, it rounds the crystals across the snow-covered areas, and rounder crystals of ice absorb more sunlight, so it compounds heating. It's one of a number of enhancement factors that is why the Arctic is warming at 2 to 3 times the rate of the lower latitudes.
I see. Scientists are now predicting that within a few years we may see an ice-free Arctic. Do you agree, and are you surprised at how quickly this has happened?
It's not surprising to see the Arctic sea ice decline in response to climate warming, and that's because of this amplifier mechanism, the same thing that's increasing melt on Greenland. It's a darker surface, more melt ponds forming on Arctic sea ice, more water. That's just a darker surface, and in those 24-hour-long daytime conditions in the summer in the Arctic, that amplifier gets to really kick in because of warming. More water, more open water, really dark surfaces. So this is the amplifier. All you have to do is warm or cool climate and the ice responds.
Yeah, if I'm remembering high school physics right, the amount of heat it takes to melt ice, that phase change point at 32 degrees, the amount of heat it takes to melt ice versus the amount of heat that it takes to warm water are like, what, 10 to 1 or thereabouts. So, once the ice melts, the same amount of heat coming from the sun is warming the water much more rapidly than it was melting the ice. Do I have that right? And does that play into this whole thing?
It's important whether or not the ice is, say, in the water, and it takes energy to elevate the temperature up to the melting point. So you can have, say, -10 ice, and it's sitting there. It's ice until you exhaust that cold content in the ice. Then you cross over that threshold, and then it just starts melting. So ice is a threshold medium, and it has a certain cold content. That we're losing that cold content not just in sea ice, but in snow cover, in permafrost, and then you hit that melting point, and then you start to see that action. Now, if the ice goes away, you no longer have that heat sink kind of reservoir. That cold content is gone, and then you're going to see a more abrupt change associated with the loss of that kind of refrigerator effect.
Right. And how does methane factor into all this, particularly in the Arctic?
So Arctic methane, either in the sea floor or on land, that's a big kind of climate change X factor. The risk is very high if that carbon reservoir can come out. I've been asking experts on this, and they're pretty cautious to say that there's any kind of methane dragon, like the rhetoric that we hear a lot of. And so all we really know is that the risk is high. But Norway, Germany, the US, Sweden, they are all have launched big measurement campaigns, expensive icebreakers, aircraft, to go and check this out. And we have to wait a little bit longer till we know just how fast it's coming out. So despite the hysteria on that very high risk issue, we don't really know. That's my sense from talking to hardcore experts. Right. We know that the risk is very high. That if warming would trigger the release of seafloor methane, terrestrial land methane, that additional carbon release to the atmosphere triggered by warming could make it that much harder for humanity to manage an already elevated greenhouse effect.
Right. So it's high risk and right now unknown probability, hopefully low probability.
Yeah, and so even if it's, because the impact is so threatening, even low probability still makes it high risk. And I'm happy that NASA and the Norwegian project, for example, that's like 40 million euros that they're spending on that very question.
Seems like
NASA has a new project called Above, and that's building on a project called Carve. So there's some heavy technology going into that. And I think for right now, we need to kind of try to remain calm and ignore some of the really hyperbolic rhetoric that you can find on the web that comes from messengers that just aren't experts on this topic.
Mm-hmm. Yeah. As a scientist and someone who speaks publicly about the dangers of climate change, how difficult do you find it to operate in an environment filled with so much disinformation, whether it's the hysteria that you were referring to, the world's going to end next week, or next decade, or the phony science funded by the fossil fuel companies?
Yeah, there's an echo chamber. Not really surprising to hear that coming from the fossil fuel industry that has a track record of funding seeds of doubt, and that's very effective. Just raising a bit of doubt can confuse people that aren't plowing through the long reports and trying to make sense, do the hardcore journalism to really understand what the science is telling us. And now we're getting some echo chamber coming from people with their hearts really in the right place, hyper concerned people developing their own blogs, mining data from various sites because there's a lot of free data out there, and sometimes weaving that into a counterproductive message. So it's a really challenging communication environment. And so I learned something key very recently from a senior person, and it came down to, you can say whatever you want provided that it's accurate. That's a high standard that we have to maintain. A way to do that is do 4 fact checks for every statement you want to pass on before doing that. And that filter will help us be accurate. And then when the facts inform us, we can make very strong statements and really stand out, knowing that the facts or that the science is as accurate as we can get it to be.
Yeah, and solid stuff. Very, very, very good. And that's basically the much of the process that the IPCC has been doing. Professor Jason Box, it's great talking with you. Thank you for being with us tonight.
Sure.